So in this video, we are going to start a new chapter called as chapter number 7, triangles. So this is an introductory video. We'll try to understand what triangles are and some basic properties of triangles. And moving forward, we'll in this entire chapter, we'll see how congruence of triangle is an important concept and how do we prove that two or more triangles are congruent to each other. But now, as for now, let's start with the basic and very simple definition of what a triangle is. Okay, so this is the definition of a triangle. Yes, so let's read it out. A closed figure formed by three intersecting lines. What a simple and a very plain definition of what a triangle is. It's a closed figure. Okay, let's use a highlighter. It's a closed figure formed by three intersecting lines. So let's try to draw a triangle. Okay. So this is a closed figure formed by three intersecting lines. It's called a triangle. Now let's try to name it. This is A, okay, this is B, and this is C. Now we all know that every triangle has three important properties, or you can say three important aspects to it. The first one is a side, so it has three sides. Okay, so I'm going to name them. In this triangle, the triangle which is there besides us, we have three sides which are AB, BC, and AC. Okay, then it has three angles. There are three angles to every triangle, and here we have angle A, angle B, and angle C. And lastly, every triangle has three vertices. Okay, vertices are nothing but these points, these three end points, you can say, of the triangle. So in this triangle, the three vertices are A, B, and C. Okay, so very simple geometrical figure. Triangle is a very simple and a very important geometrical figure, because in most of the things that we see around us, even in our day-to-day life, a lot of structures are actually triangular in shape, and they have very interesting mechanical properties or even engineering properties. Anyway, we are not going to get into that. So this is a simple definition of triangle, which is a geometrical figure, a closed figure formed by three intersecting lines. These three properties are very important because going forward, we are going to use these three properties of a triangle in order to prove the congruence of a triangle, or in order to prove that two triangles are not congruent as well. Sides, angles, and vertices. Now, let's move ahead. Now, we want to understand, I'm going to remove this, congruence of triangles. Okay, so first let's see what is the meaning of congruence. Congruent, the word congruent means equal or same in all respects. Now this is very important point. Two figures are said to be congruent to each other. Any two geometrical figures, I'm not just talking about triangle, even if you take two circles or even if you take two squares, they are said to be congruent to each other if they are equal or same in all respects. Now when we say in all respects, what does it include? Now specifically in case of triangle, here as we have seen here, when if you want to say two triangles are equal, it should be equal in all these aspects. What are these aspects? Sides, angles, and vertices. Okay. So congruence of triangles will involve equality or same in all these three respects: sides, angles, and vertices. Okay. Now in order to understand a bit more about congruence of triangles, let's do a small activity. I'll get rid of this. Okay, let's do a small task. What does the task say? We are given here five different triangles. Okay, now which of the triangles below are equal to triangle ABC? Okay, so first let's highlight triangle ABC. So this is, okay, I'm going to use a different color. So this is our triangle ABC. Yes, and we have to, and then these are other four triangles given to us. Now out of these four triangles, there are some triangles which are equal or congruent. I'll better use the word congruent. Equal and congruent are same, but just congruent to triangle ABC. This is triangle ABC. Now as we have seen, if two figures or two triangles are to be congruent, all these three aspects of the triangle should be equal. So let's see one by one which triangles satisfy this property. Now first of all, uh, let's focus on the sides of the triangle, So you can see ABC has sides 4.5, 5, and 4. Okay, so let's start with this triangle, triangle PQR. I'm going to zoom in a bit. Yes, So 4.5 is there for, okay. In fact, we can use a highlighter now. So this is 4.5. So this has 4.5. This has 4.5. This has 4.5. Now here you can see none of the sides are 4.5. Okay. Which means this triangle can never be congruent to this triangle because there is one side which is not equal to each other. So very straightforwardly we can cross out this triangle. It can never be equal to triangle ABC. Now let's go to the another side. So I'm going to take another highlighter. 4 centimeter. This has 4 centimeter. This has 4 centimeter. This has 4 centimeter. So okay, two sides are equal. Now let's go to the third side. This is 5 centimeter. This has 5 centimeter. This has 5 centimeter. This has 5 centimeter. So now step 1 is completed. We checked all the three sides of the triangle and we saw that whatever sides ABC has, the same sides PQR has, the same sides DEF has, and the same sides MRN has. So the side test is passed. Now let's go to angle test. Now I'm going to use again the same highlighters. So this is angle A. So as you can see, okay, let me first uh, point out an important point, that as you can see in angles, this is how they have. So this is one line, these are two lines, and these are three lines. Okay, these lines, like one line, two lines, and three lines, these lines indicate the measure of the angle. Okay? That is an important point to be understood. I'll just erase this. Okay, so let us begin. So A, so this is single line here. So this also has a single line, angle P, angle F, and angle M. So all the three have equal measure. So measure of angle A, which is denoted by single line, is equal to angle P, angle F, and angle M. Now let's go to next. So this is B. B has two lines. So Q has two lines. In this triangle, D has two lines. In this triangle, R has two lines. So again, this angle is also equal to each other. And the final angle is C, which is three lines. So even this triangle has three lines, this triangle has three lines, and this triangle has three lines. Now, thus, all the three sides, if you compare triangle ABC with these three triangles, all the three sides are equal, all the three angles are equal, which means that these four triangles are congruent to each other. They are actually same. The only difference is that this triangle ABC has been tilted. Okay, it has been tilted and represented here. This has been tilted and represented here. There is some rotation they have done and they have represented here. So when you look at just with your eyes, you might think that these four triangles are different, but that is mere rotation that is done. Otherwise, if you see, all the three have same sides and all the three have same angles. Again, this is important point in terms of congruence of a triangle, okay, that it has to be equal and same in all the respects. So thus, this is how we prove that one triangle is congruent or equal to another triangle. So that is an important point to be noted. Now, one more point to note when we talk about congruence of triangle is one-to-one correspondence. So I'm going to remove this. Now, what is one-to-one correspondence? Let us take these two examples. Okay, so what I'm going to do is I'm going to hide this so that it's easy to discuss the one-to-one correspondence. So let's hide this. Yes. Okay. Now let us focus on these two triangles, triangle ABC, okay, and triangle MRN. So I'm going to write it like this: triangle ABC and triangle MRN. Okay, and this is a sign of congruence. These two triangles are congruent to each other. So this is how you note, or this is how you denote the congruency of two triangles. Okay, let me do it a bit nicely. Okay, now what is one-to-one correspondence? So when we say triangle ABC is congruent to triangle MRN, we actually mean that angle A is congruent to angle M. So look at this, angle A is congruent to angle M. Then angle B should be congruent to angle R. So angle B is congruent to angle R. And angle C should be congruent to angle N. So angle C is congruent to angle N. We cannot say, for example, we cannot say that triangle ABC is congruent to triangle RMN. Okay, I have just changed the notation of the triangle. Instead of calling it MRN, I have said RMN. When we say triangle ABC is congruent to triangle RMN, it means that angle A is equal to angle R. But in reality, angle A is not equal to angle R. Angle A is equal to angle M. Okay, so one-to-one correspondence. One-to-one correspondence means the way you denote the congruency of triangle is also very important. You cannot write any random combination of alphabets A, B, C and RMN and just say that those two triangles are congruent. The order in which you denote it is very important. So I'm going to erase this. Yes. So triangle ABC, oh sorry. So triangle ABC and triangle MRN are congruent to each other, not other random combination. We just saw the noted them in terms of angles. You should also test them in terms of sides. So for example, now I'm going to use a highlighter. AB is congruent to MR. Let's verify this. AB is congruent to MR. Okay. Now let's go ahead. So BC is congruent to RN. Okay. So let's confirm. BC is congruent to RN. Yes. And finally, we have AC is congruent to MN. So AC is congruent to MN. Okay. So once again, the way you write is very important. If you mess up this, okay, if you say, okay, if you say triangle ABC is congruent to triangle RMN, exactly what I wrote sometime before. Note that not only the angles get messed up, but the sides also get messed up. If you give this notation, it actually means that AB is congruent to RM. Is that the case? AB, which is 4.5, is it congruent to RM? RM, oh, AB and RM gets satisfied. Okay, but something will not get satisfied. BC and MN. So BC is 5 and MN is 4. So thus they are not congruent to each other. So once again, if we mess up, I am going to erase this. But just to highlight, if we mess up the notations of two triangle congruency, then the whole angle to angle, side to side correspondence also gets messed up. So the way you denote the congruency of triangle has to be very carefully done. So I'm going to erase this. Now, as an exercise, now we can very safely remove this. As an exercise, let us denote the congruency of these two triangles. Okay, PQR and DEF. So again, it's very simple. You have to just focus on the angles. So I'm going to say triangle PQR here. Okay. Now look at angle P. Angle P is congruent to angle F. Okay. So I'll just make like this, a mark. So P is congruent to F. Okay. Then Q is congruent to D. So one-to-one correspondence. Q is congruent to D. And finally R, only one angle remaining. R is congruent to E. So R is congruent to E. So we have to say, so triangle PQR is congruent to triangle FDE. Okay. The notation is important. The order is very important. FDE. You cannot say DEF or EFD or any other random combination. So triangle PQR is congruent to triangle FDE in that order. Note this also satisfies the sides congruency. So PQ and FD. So let us cross check. PQ 4.5, FD 4.5. Next, we have QR and DE. So yes, QR is 5 centimeter and DE is also 5 centimeter. So angle to angle congruency is also satisfied. I don't know why that happened. Anyway, so angle to angle congruency is also satisfied, and side congruency is also satisfied. So this is the overall concept, which is very important concept of one-to-one correspondence. That's all.